Hello friends, in this lecture we will see rotary floor operation, and this is rotary mill rotary. This will come under mill rotary, and we can use this for uh, cylindrical part. So first I am going to create geometry, so click here, and my work geometry is workpiece, and that is come under the geometry. Okay, and my part is this. Okay, and blank. For blank, I can use bounding block, bounding cylinder, or I have already created a geometry, so I am using this geometry as a blank. Okay, now this is the geometry and this is under the geometry, so I can drag and drop this to MCS. See, this will come, and because I'm using this rotary operation, so this rotary geometry will create. Otherwise, we can go and we can select from mill rotary. This is the rotary geometry. So I'm going to define this geometry, and first I'm hiding this outer shape. So floor and wall, so my floor is this outer one is my floor. I want to cut this, and wall, my walls are, these are walls, add, and second set is this. Okay, and part axis is Z, so we can define my axis of revolution. I can specify, so in this case I'm using this G axis. Okay, now first I'm going to apply a multi-axis operation for roughing. So my operation is, no, I'm not using this one. I'm going to use variable contour and program. Okay, program, and my tool is 8 workpiece 1. No, I'm using workpiece, and my method is rough. Okay, and first I'm going to create for this phase roughing operation. So my cut area is this outer, and tool already defined. My drive method is surface, and projection vector is normal to drive. And now I'm going to specify my drive geometry, and my drive geometry is this surface. Okay, and here I'm using zigzag as a cut pattern, and number of step I can enter a number of step or distance, both I can define. Okay, and from the axis, go to this axis. Here my tool axis is normal to part. You can see normal to part is my geometry, this tool axis, and from the main projection vector is normal to drive, and verify. See, this projection vector is highlighting now. Okay, and generate it, and before this go to non-cutting, and here I am using cylinder, and my axis center is this, and vector is along Z, and radius I am using 60. Let's see. Okay, it is a little bit smaller, so enter the 80. Now it is okay. Now generate. The program is creating in a single toolpath. Okay, if I want to apply multiple depth, so here we have multi depth option. Suppose it is 2.0 the thickness of this outer surface, and 1.0 I'm selecting as a increment. So in two step it will roughing operation will take place. Okay, let's verify it. So from this replay, okay, how it is working. And in 3D, so first this is my roughing operation, and for finishing I can use rotary milling. I have not selected this inner portion, so it has skipped this portion. Click OK, and from the main I'm going to add this surface also in cutting geometry, and let's generate it again. Now the toolpath is creating in this space also. Let's OK. Now you can drag before this. Now I want to generate my operation for this rotary geometry. So go to this mill rotary, and my operation is this rotary floor, and tool is this ball mill. Ball mill will support for this mill rotary, and geometry is mill geometry. Okay, and this is my finishing operation. Okay, all the geometry floor and wall are already defined, and axis of revolution is z. It is right. Direction around axis is z, so around the z. And cut pattern is zigzag. Cut direction is mix, and this group height a constant or number of passes we have. Okay, so I'm using this by default value. Just generate, then we will make any other changes. So this is the toolbar. Okay, and go to non-cutting, and this common clearance I'm using cylinder, and as I have done in variable control, same I am doing for this, so that this non-cutting move will move smoothly. 80, and let's see. Okay, it is okay. And here cuts extend step value, no problem. All the options are same. Cut step is this. Okay, maximum cut value, the distance between two cuts, axes are already defined. So minimum lead angle is minus 30 degree. Go to main, and material side we can skip, but this time it direction is properly, so no need to change. Just generate it again. Non-cutting move will show you the proper cylindrical non-cutting move. If you want to see this, generate. Tool is a little bit bigger. Okay, okay, and okay to finish. For this inner portion, if I want to generate a finish operation for this face, so I'm going to create new work geometry, rotary geometry, and that is under this workpiece, and this time this is geometry 2.0. Okay, and my floor is my cutting geometry, and wall is faces around the floor. Part axis is Z. Okay, and now I'm selecting the same, but this time my geometry is this 2.0, and my finishing operation tool I'm using the same, and the rest option are the same. Okay, I'm not making any changes here, just generate, and it will calculate and it will generate another finishing operation for this. Okay, let's see the simulation. It is computing IPW in process workpiece. Okay, now the some material are still remaining on this corner because of larger tool, so I can generate another operation for this wall. So okay, and finish this operation and go to multi-axis, and here I have this contour profile, so I'm using this contour profile, and my tool is milling, and geometry is this workpiece. This workpiece is my geometry, and I want to use finish operation, and first display the tool. Okay, let's see. Okay, I'm using this tool, and my floor is part is already specified. Floor automatic wall, it is not selecting the face. Okay, this is the first face, select, and another face is this, so add new set, and this one. Okay, and automatic wall, let's see the wall. These are the walls, so this toolpath will generate according to the wall, so it is necessary to this highlight this walls, so that we can find the toolpath will generate where the toolpath will generate. Okay, and rest no need to change any axis and all, so this will work directly, and my axis vector is Z, and let's generate. If it is required, just change your non-cutting move and into the wireframe. Okay, I'm showing you. Okay, now I want to add the material is material is not cut in single pass, so I want to add multiple pass, so go to strategy, and here we have this multiple side pass and multiple depth, so this time I'm adding three multiple pass, generate, it is not showing the multiple pass. Okay, and sorry, I forget to change this increment. The increment must be less than 3, then only it will show you the multiple passes. So I'm selecting this multiple side pass, and increment I'm selecting as 1, so 3 passes will come. Okay, and for this thing I've already told you, go to non-cutting mode and cylinder, and specify the point. Vector is z, and 80, generate it again, so it will move in circular manner. Okay, so it will look pretty well. And the third one. Okay, so this is the way for floor and wall.